Hello everyone, today we will do some physics lesson. In this chapter we will learn about the hydrostatic pressure and its applications. That is actually in the local syllabus, grade 10 book, chapter 15. 11 new students, some of the students in 11 new classes requested to do this chapter as a revision. So that's why I selected this chapter, and even though if you are studying in the Cambridge syllabus, you also can watch and gain some knowledge. And for those who don't know about me, I am Dr. Vatsala S. Jayasinghe, working in the health field. Also, I have been teaching science for more than 12 years. So, let's go to the chapter. That's chapter 15 in the grade 10 book, that is hydrostatic pressure. Hydrostatic pressure and its applications. Before starting the chapter, you should have a rough idea about what pressure is. Already you have studied about the pressure in previous classes. So, pressure is something like a feeling of squeezing. That is the pressure. And also pressure can be in any matter. It means already we know that there are three types of matter. They are solid, liquid and gases. So pressure exerted in solid matters, already you might have studied in the previous classes or the grade 9 or 10 classes. In there you have studied about this, and also there you studied the formula, force over area, etc. And this chapter is mainly based on the pressure exerted on liquids, that is the hydrostatic pressure. So we will learn deeply about this chapter, and this is a very important chapter. Most of the MCQs and sometimes structured essay or the essay questions can come out of this. So let's learn about this. So first of all, write down the main topic, chapter 15, grade 10, hydrostatic pressure and its applications. They write down pressure. Pressure is the feeling of under the pressure. Pressure is the feeling of squeezing. It acts on solid, liquid and gases. And for the solid matters, the formula is F over A. Now let's see what is this F and what is this A and their units. Okay. Now for the solids, it is pressure is force over area. This force is not just force. This force is actually the perpendicular force. Okay, keep in mind that word, perpendicular force over a unit area. So when you just hear the perpendicular word, you get the idea. That means it should be angle. That angle should be 90 degrees. So if the object is like that, and the force must be 90 degrees to it, then you have to divide it with the area. That is how the PA equals F over A has come. So in detail you might have studied, or we will study later. In here we do a quick revision only. Keep in mind that. And now let's see what are the measuring units of it. What are the measuring units of it? Now force is measured in what? Newton, yes. And area is measured in square meters. So you can write it Nm minus 2. Sometimes they can ask, find the pressure in fundamental units. Okay, especially in the Cambridge syllabus, they can ask, find the pressure in fundamental units. What does it mean as fundamental? Fundamental means the basic units. Okay, now we know force is equal to MA. That also you have studied in another chapter. Previously you might have studied, according to Newton's law, force is equal to MA. M means mass measured in kilograms. A is acceleration measured in ms minus 2. So now you have to apply. Instead of F, without applying Newton, you just apply this one, kg ms minus 2 divided by square meters then. So with the calculation you already know, this to this can be gone. So it is kg m minus 1 s minus 2. So in any case, if they ask pressure in fundamental units, you better not to write with Nm minus 2, you better write with this, because these are the fundamental units. Anyhow, now even for the Nm minus 2, as an honor to Pascal, they have given 1 nms minus 2 is equal to 1 Pascal. Now keep in mind, this is the SI unit of measuring pressure. Now if they ask, what is the SI unit of measuring pressure? It's Pascal. So 1 Pascal is equal to 1 Nm minus 2. This is the fundamental unit. As an example, let's take 10 Nms minus 2 is equal to 10 Pascal. So 2 Nms minus 2, Nm minus 2 is equal to 2 Pascal. Likewise, keep in mind 1 is equal to 1 here. Okay, that also you have to keep in mind, then only it will be easy to make calculations later. Now let's learn about the pressure. Now let's move to the topic hydrostatic pressure. Hydrostatic pressure. So already I told, hydrostatic means pressure exerted by liquids. Pressure exerted by liquids. And here you are not going to talk much about that. You will learn about the characteristics of hydrostatic pressure, and also you will learn about the transmission. These are the things that you will learn about hydrostatic pressure. Write down the next subtopic. Under that, write down hydrostatic pressure means pressure exerted by liquids, and there you will learn about the characteristics of hydrostatic pressure. Also you will learn about the transmission. And what do you think? Pressure is a vector quantity or scalar quantity? Okay, what about pressure? Is it a vector quantity or scalar quantity? Pressure is actually a scalar quantity. Why it is scalar quantity? What is the difference between a vector quantity and a scalar quantity? Vector quantity means they have a magnitude and a proper direction. Okay, when we talk about the scalar quantities, they have magnitude only. They don't have a proper direction. The directions may change with the time. Okay, so pressure is, keep in mind, pressure is a scalar quantity. Write down with red star mark. Pressure is a scalar quantity. The SI unit of measuring pressure is Pascal. The SI unit of measuring pressure is Pascal. Now, in your syllabus, you have given 3 practicals to be done. Okay, in one practical, you have to take a polythene bag. I'll write it there. You have to take a polythene bag with some holes and fill it with water, better with water or any other liquid. Then the water will come out through these holes. Okay, that's the very first practical. Now in the second practical, there you have to take a plastic bottle. There in the same height, make some holes and fill it with liquid water and see how they come out of the bottle through the holes. And as the third practical that they have mentioned, again take a plastic bottle about 25 centimeters long and there keep some holes in different levels and fill it with water, then check the direction how they move. These 3 practicals are there. So these 3 practicals you can do at home. You can find shopping bags and these plastic bottles easily. So you can do and check what happens there. So based on these practicals, they have given you the characteristics of liquids. So rather than just memorizing the points, if you can memorize them with the practicals, then it will be easy to learn. So let's learn what can we get from the first practical. From the first practical, it says, see there, the water comes out from 2 different directions. So first of all, from this practical, what we can get is it acts on every direction. So hydrostatic pressure acts on every direction. From this practical, that can be proved. From the second practical, when you measure the horizontal distance of the flow of the water, that there you can find it is equal. Horizontal distance is equal. horizontal distance is equal. So there, from that you can get an idea, pressure at the same level. Pressure at the same level is equal. Okay, horizontal distance is equal means the speed is also equal. So from the second practical, what you can get is pressure at the same level is equal. Okay, now from the third practical, here you can get an idea. See, when the distance is more, we have to measure from above. I'll mark it as A, B, C and D. Okay, I'll mark it as A, B, C, D and D. There, speed of streams water. Now here A has the higher speed, B speed is lower than A, in C speed is lower than B, in D speed is the lowest. So from that what you can get, the liquid, so the speed increases with the depth, that idea you can get. So from that you can get an idea, pressure also increases with the depth. Okay, with the depth. So these three characteristics are proved with these three practicals. So write down next subtopic, characteristics of liquid pressure. So write down. If you want, you can mark these if you want to refer, but already we have done this properly. So write down first one. At a given point, pressure is same for all direction. And the second one, pressure at the same level is same. As the third point, pressure increases with the height. And additionally you have to add this one, pressure does not depend on the shape of the container. That's what you can get. These are the 4 characteristics of hydrostatic pressure. Okay. Now let's learn about the units of how to measure this one, and with which formula that we are going to measure this. We already know P equals F over A. So even though it is a gas or even though it is a liquid, the pressure definition is same now. So here force, we can write force is what? Now if the container is filled with some sort of a liquid, okay, imagine this is filled with water. Now these water particles will give some sort of a heaviness and will be created a force. This force is what? This is equal to weight. Okay, weight means what? Mass into gravitational acceleration, W equals mg. So instead of F here we can put mg. Okay, over area. And we studied about the density chapter. There we studied about what? Density is equal to mass over volume. Now instead of mass, just subject mass here. Mass is density by V, rho by V. So instead of M, just write rho V G A. Now what is volume? Volume means area multiplied by height. So instead of V, let's put AH, rho AHG divided by A. Now area to area can be cut. So it is H rho G. Now this is the formula for hydrostatic pressure. That's what? H rho G. H means height, it should be measured in meters. Rho means the density of the particular liquid. G is gravity. Okay, that's the thing. So this idea must be there. Now for the exams they will ask many questions based on that. Calculation part we will do more in practical class. Just a summary is given. So for those who don't know about this, this is just a summary. Okay, rather than that, in detail we will discuss in physical class. So this formula is a must. You must know about it. That is P equals H rho G. Write down next subtopic, not a point, not a subtopic, as a point. P equals H rho G is the equation we have to use to find hydrostatic pressure. Now let's learn about the transmission of pressure. Transmission of pressure. Okay. Now let's learn about the transmission of pressure through liquid. Already we studied now pressure at a given point in a particular liquid is same. Now I'll take this as the point 1, point A as the point B. So there are two pistons there. So pressure in here must be equal to the pressure in here. Okay, that's a must. That's what we have studied. Pressure at same level should be equal in a particular liquid. Now here you can see 20 Newton force is applied from the piston A and the area is 10 square meters. So here the area is higher. Okay, so now there is a thing that means F over A is equal to F over A. Now here it is 20 Newton, no? It is 20 Newton here, and the area, since it is in square centimeters both of them, I am not going to convert them. I will just apply as they are. 10 square centimeters is there, and the force we don't know. What is the how much of a force is applied on piston B, that we don't know, that we have to find, and the area is 200 square centimeters. So we can cut like this, and once when the calculation comes, F should be 400 Newton. Now just imagine and look at the direction also. Just imagine by applying a 20 Newton force from the other side, that we can get a force of 400 Newton. So the same mechanism is used when lifting vehicles, and in the brake system of vehicles the same system is used. So this is known as transmission of pressure through liquid. Write down next subtopic, transmission of pressure through liquid. Under that, just draw this figure soon and write down machine constructed to operate based on the principle of this. Based on the principle of this is known as hydraulic press. Some examples for that hydraulic press are hydraulic jack, that what we use to lift vehicles also, and vehicle brake system. So these are the things that you must learn in the part 1 of the regarding the calculation and the regarding other parts. That means atmospheric pressure is also there, we have to study. Those things will be studied in another video. Thank you.